Welcome to Quadratic Equations. Introduction. The word quadratic comes from the word quadratus, the Latin word for square, and this is St. Peter's Square in Vatican City, and this is because it's a square in Rome where Latin was spoken. In institutions of higher learning, such as the University of Illinois pictured here, central open areas used for student leisure and for traveling between buildings are called quads. Quadratic equations create the shape of a parabola, whose general shape is used in arches, building construction, parabolic dishes for receiving and focusing electromagnetic wave particles, focusing a light source into a beam as in a flashlight, and for tracing or calculating projectile motion. Quadratic equations are used in electronics, optics, to find the stopping distance of vehicles, navigation, economics, and perhaps its very first use in our world to calculate distance and area. As we continue with this lesson and lessons on solving quadratic equations, the processes may seem to be very dry and academic, but I hope you'll remember that real-world uses are never far away from what we're doing with quadratic equations. Muslim mathematician Muhammad Al-Khwarizmi, whose book title had the words that transliterated became the word we now use for algebra today, used the completing the square method to solve quadratic equations. He didn't have the algebra notation of letters for variables. He didn't even have an equal sign. So he wrote it out verbally. But as you learn about completing the square method, you will be using the same technique that Al-Khwarizmi used and explained in the 9th century AD. Working with quadratic equations became useful as government and commerce were becoming modernized and accurate calculations of land area became necessary. This basketball player, while making the shot, unconsciously programs a quadratic equation path with the purpose of tracing an accurate parabolic trajectory through the basketball hoop. One of my favorite math teachers on YouTube, MathGives, made a video introducing quadratic equations and offers this explanation. This is Joe Quadratic, a basketball player, with his equations. We're going to look at how a quadratic equation comes about. Here Joe has a linear equation, something like you've seen before, 3n plus 5n minus 2 equals 0. His first step might be to say, I'm going to take this minus 2 and move it over to the other side of the equal sign where it changes to positive 2. His next step would be to join these two n terms together, where together they make 8n, 3 plus 5 equals 8, so 3n plus 5n equals 8n. His next step is to look at what it takes to get n by itself to solve for n. Since n is multiplied by 8, he solves by dividing both sides of the equation by 8. 8 over 8 on the left side cancel each other to equal 1, so he's left with n equals 2 over 8, which simplifies to 1/4. But he rewrites this in decimal form as n equals 0.25. Everything is right with the world. The birds are singing and everyone's happy. Now let's look at the right-hand side here, and we see that we have the same equation except for one little distinction. Here, above and to the right of that first n, there is a little 2. Right away, this takes away that first step used in solving the equation to the left. He cannot take 3n squared and 5n and add them together. They are unlike terms. So right away he has a problem. This is what a quadratic equation looks like, and this is the problem or challenge that is presented. In this video series, we'll explore different methods of solving this and dozens of other quadratic equations. Now we'll go over the general form of a quadratic equation. This is the first term of a quadratic equation. Note that it has a squared sign. Remember that the word quadratic comes from the word quadratus, which is square in Latin. And this is the second term of a quadratic equation. It has the same letter as the squared term, but this letter is not squared. We have a 0 on the right side. If this number on the right is not 0, we will usually try to make that right-hand side of the equation equal 0 to solve a quadratic equation. We have some number represented by this letter A times that x squared. The number may be 1, and if it is 1, we will not need to write down that number because no number in front of the letter assumes 1. We can have some other number. Well, it really could be the same number as the a that multiplies the second x in the equation. We call that letter b. And the number b is added or subtracted. We put a plus sign here now, but this could be a minus sign if this number b is a negative number. And quite often we'll have some number at the end of the left side of the equation which is added or subtracted, and that we call c, that does not have a letter after it. This is your general or standard form of a quadratic equation, the form ax squared plus bx plus c equals 0. This first term with the x squared is your quadratic term. This is what makes it a quadratic equation. This second term is called our linear term. This term by itself, if graphed, would form a line. And finally, this third term, c, is called the constant term. It always has the same constant value, no matter what x is. With no x next to it, the value of this term never changes, no matter what that value of x is. So that's why we call it a constant term. Let's look at some examples in the lower left corner of the screen. 5x squared plus 2x minus 3 equals 0. Or you could have x squared minus 6x plus 2 equals 0. Or you could have 2x squared plus 5 equals 0 and have no linear term. Or you might have 5x squared minus 2x equals 0 and have no constant term. And of course, the right-hand side may not start out to be 0. You could have 13p squared minus 5p, and you might have a 7 on the right side. The right-hand side does not have to start out to be 0, and you can have letters other than x, like p, like we have here, or q's, or s's, or r's, or whatever. These letters, however, should always be the same in a quadratic equation. The letter in of the x, for instance, in the quadratic term and the linear term. And this is your whole family of quadratic equations. What do they all have in common? Well, something with a squared sign. From here we're going to progress toward learning how to solve them. Because of the squared term, we need to use different techniques for solving than we would use with linear equations, and these techniques will be showed in future lessons. And here are the 5 different methods of solving quadratic equations that we'll be covering in my series. We have the square root method, solving by factoring, solving by graphing, using the quadratic formula, and completing the square. You may click on any of these to go on to that particular lesson. In addition, there's a solving quadratic equations flowchart that filters you through the different techniques of solving these equations. This has been Quadratic Equations Introduction. Thanks for viewing.